And now we are going to hear a team from the University of Barcelona, Miquel López Garcia and Margarita Díaz Andreu. They are going to tell us about Neolithic shell trumpets in Catalonia and archaeoacoustical approach. The floor is yours, Miquel.
Thank you very much, Zorana. Let me share my screen. Welcome everybody to this presentation, and thank you very much to the organizers for accepting this proposal. We would like to start with a traditional riddle from Mallorca that says, what is the animal that cries when its flesh is consumed and when it's alive says nothing? The answer, as you probably already know, is the shell trumpet. Shell trumpets are sound instruments made from large seashells, usually from gastropods from the genus Charonia, which are played in many different cultures with different names, as putatara in New Zealand, shangha in India, pututu in Peru, or bursa in Tanzania. This multiplicity of names can also be found in their uses, which may be ritualistic and religious, military, or for signaling, as this last case from a navigator in Tanzania. And we have prepared another small riddle for you. Do you think this is a shell trumpet? It could seem so, but no. To transform a seashell into a shell trumpet, we need to practice different transformations over the skeleton of the animal. The most important one is the removal of the apex. Cutting the finest part of the spiral of the seashell, it's very important, as this is the part where the musician will put his or her lips to sound the instrument. But there are also other optional transformations, like, for example, the trimming of the outer lip, you can see in that image, or the creation of suspension holes, like this one you can see in the opening of the seashell. Suspension holes were used to carry easily the instruments using ropes or belts. This is a map published by Marano in 2018, where the author tries to summarize some of the main shell trumpet findings in Europe from the Magdalenian period, with the example from Marsula's cave in southern France, to different instruments from the late Iron Age, both in the southern Iberian Peninsula and the Aegean. We zoom in Catalonia, and we find that at the beginning of our research, we only knew shell trumpets coming from 3 archaeological sites, Mas d'en Boixos, Mines de Can Tintorer, and Sant Jaume Mas d'en Serra. This last one being the only one well published. After many months of research, we know now shell trumpets coming from all of these 12 archaeological sites with a minimum number of 20 shell trumpets, 12 of them from a Neolithic chronology. And as our project, the Artsoundscape project, was focused on prehistory, we decided to focus in these 12 specimens from the Neolithic period. A new publication is coming later this year about this topic and these shell trumpets from the Neolithic period. We started our study with taxonomy and biometrics analysis. We found that all the 12 shell trumpets were made with the species Charonia lampas, the most common one in the Mediterranean Sea, and they had various sizes and levels of conservation between 104 and 191 millimeters of maximum length from the apical cut to the siphonal canal in the other side of the seashells. They also had frequent biological marks that indicate that they were not collected for food purposes, but for other ones. Lastly, they had intentionally removed apexes as we checked using a digital microscope. But our main focus was in the acoustic study, where we found interesting patterns. For example, this tonal pattern. 7 out of 8 trumpets have a fundamental frequency between approximately 400 and 470 Hz, which could indicate an intentional selection of specimens based on their size. Moreover, these results are significantly higher pitched than those from other study areas where archaeological shell trumpets have been found, such as the Italian Ligury or Peru in South America. And there's also another interesting acoustic pattern referring to the maximum sound pressure level playing the fundamental tone at 1 meter, measured with a class 2 sound meter. Again, 7 out of 8 shell trumpets have maximum sound pressure levels higher than 100 dBAs, which means really strong sound emission. Only one case, the first one from Masten-Boschus, has a value less than 100 dBAs, and this is probably due to the bad conservation of this instrument. Now we would like to highlight 2 cases. The first one comes from Masten-Boschus archaeological sites, located in Vilafranca del Penedès, 40 kilometers southwest from Barcelona. There were found 3 shell trumpets, 2 coming from reused pits and 1 coming from a pit burial in the image. This one is the only example from a mortuary context in Catalonia. If we zoom in this instrument, we can see the main feature of the piece, which is a step in the apical opening. This greatly complicates the interpretation of the instrument and causes discomfort to the performer. Therefore, we propose 2 hypotheses. The first is that there once existed a mouthpiece that has disappeared. And the second is that it was not played in a centered manner, but rather with a lateral embouchure, that is, fitting the opening not to the middle of the lip, but to one side, a fact that would facilitate the alignment of each shape with the anatomy of the lips. But the most interesting case probably comes from Gabon Neolithic mines. These mines were exploited during the Middle Neolithic to extract bauxite, and there were found 6 shell trumpets. 4 of them still keeps their ability to produce sound, and are the ones that appear on this image. In Gabon, we realized we had an awesome opportunity to experiment with original Neolithic instruments in original Neolithic spaces. So we decided to try and to check the acoustic of the shell trumpets inside the mining galleries, as you can see in this video. This is the map of one of the mines where we decided to experiment. We located 3 different points of measurement, and on each one of them, we positioned both the sound source and the sound receiver. And now we will show you the results with the sound source located in the point number 2 and the receiver located in the point number 3. Here you can see a spectrogram of the recording of the shell, of the biggest shell in our studio sample. We played 3 notes in the fundamental tone that you can distinguish perfectly with these landscape lines. But you also can see these vertical lines and the background noise below that correspond to a recreation of the background noise of the mining activities that we decided to carry out in the mine itself, with 3 people dragging and striking stones at distances between 2 and 6 meters from the receiver. Later, we mixed this soundscape at level with shell trumpet recordings. As you can see, despite the recreation of the background noise, the trumpet was perfectly recognizable. And the same happens with the smaller and high-pitched shell trumpet in our studio sample. As we were noticing that shell trumpets were perfectly audible even with this background noise recreation, we decided to try with other kinds of sound sources, human-made sound sources. For example, clapping and shouting. Clapping was impossible to hear, but shouting was audible, but not with the same power, as you can see in the pictures, than the shell trumpet, of course. To sum up the experiments in Gabá, all Neolithic shell trumpets were audible from all the measurement points and also shouts. But shells were much more strong and powerful than shouts. This could not be significant in silent conditions like the one we had during the experimentation, but it could be so in long distances and dense auditory environments like that we suppose it was during the Neolithic period of activity. During the experiment, we also checked and realized the importance of auditory perception in a dark place where it's really difficult to see farther away from 2 meters from you. And we also found different parallels of shell trumpets all over the world being played in under-earth spaces, like for example in the Hallstatt salt mines from the Iron Age, in the Marsuelas cave from the Magdalenian period, and in the temples from Chavin de Huantar in Peru. But probably one of the main parallels it's perfectly represented with this signal you can see in the image. This signal comes from a query in the United States and says, blast warning, 3 horns, 5 minutes to blast, 2 horns, 1 minute to blast, and 1 horn, all clear. And this means that the auditory perception and the sound signals with horns, these clear tones and high intensity tones, are still nowadays of key importance in risky activities such as mining or quarrying. In conclusion, Catalan shell trumpets have an intense and localized occurrence during the postcardial and early Middle Neolithic, with a minimum number of 12 individuals. For this reason, they may serve as chronocultural markers for these periods. Are found in a variety of contexts, registered pits, pit burials, mining galleries, etc. And one of the most likely uses was as signaling devices over long distances, as we checked for their strong power. Their appearance may be related also to new economic activities and ways of engaging with the landscape, like the maritime commerce, the expansion of agriculture, mining, and other activities that appeared during the postcardial and Middle Neolithic in Catalonia. Thank you very much for your attention.